All right, what's up, everybody? So this video is intended to introduce you to this new statistical analysis, an analysis of variance, or for short, ANOVA. We're also going to learn about this concept called post hoc tests, and we're going to learn a little bit more about that as we move through this presentation. But post hoc tests are a very important component of being able to run analysis of variance tests. So as you know, I always want to make sure that I'm letting you know how it is that the material we're covering now is building on concepts that we've already addressed in our class. So ANOVA is going to build on mean. We've learned about mean. We've been able to use it several times throughout this semester. It's building on also sum of squares, which we haven't really discussed independently. Since we were first introduced to this way back in measures of variability, we learned about the sum of squares as one component of being able to then calculate variance. But we're going to lean a little bit more on learning about how the sum of squares is relevant to this particular test by itself. We're also going to expand on our understanding of how and where variance is calculated and how it's applied in this particular test. We're expanding on hypothesis testing. We're also going to expand on our understanding of the t-value. It's going to transform for this test into what's called the F statistic, but we'll learn about that in just a moment. So with t-tests, we're able to compare means to determine statistical significance. So this is a callback to our previous module of content where we're learning about the t-test and how it gets applied. We learn about the one sample t-test where we are comparing a sample value to a known population reference. We learned about the independent samples test where we are comparing the means of two unrelated groups. And then we also learned about the dependent or paired samples t-test where we are comparing the means of two related groups. Now, what's important to really emphasize about each of these three tests within the umbrella of t-test is that their goal is to compare two groups, all right? However, what happens when, as behavioral scientists, we want to compare more groups? We don't want to just compare two, we want to compare three or more. That's where this new test is coming in. That's where we have the ANOVA. ANOVA allows us to be able to compare three groups simultaneously. And the goal is still effectively the same, where we are trying to determine statistical significance. So with ANOVA, because we are trying to compare the means of three or more groups, our null and research hypotheses are going to be modified a little bit from what we were introduced to with the t-test. So for the null hypothesis in our ANOVA, we are making the claim that all of our means are the same. So remember that the null hypothesis is saying that there's no statistically significant differences between our groups. And remember that as part of inferential statistics, we are taking our samples and they are intended to be representative of the populations that they represent. So with the null hypothesis, we're saying that each of the sample mean data that we are collecting and comparing to each of our other samples, all of these sample means are going to be the same, which means their population data is also going to be the same. And if they are the same, then there's no statistically significant difference between them. On the other hand, for our research hypothesis, we're making the opposite claim. With this, we are saying that there is going to be a difference, or the language of that becomes a little bit trickier because as we describe a difference, notice that the language of this research hypothesis is that they are not all the same. And we're not necessarily identifying where a difference may be happening. And so that's where we're going to learn a little bit more about the post hoc test. And like I said, we're gonna take a look at that in just a little bit.